Okay, so this is the Chapter 7 review for intermediate algebra. So the first kind of problem we're going to start with is, suppose I have the expression 3 over x minus 3. And I want to see if I can evaluate this expression where x equals -2. Well, if I plug in -2 into there, what happens? I get -2 minus 3. I just keep breaking it down. 3. -2 minus 3 is -5. So it's just -3/5. The next type of problem is, suppose I have an expression now. It says 8 over x squared minus 4. So for this kind of problem, they ask about find where the function is undefined, or not the function, the expression. So, okay, let's think about it. This is division, right? 8 divided by x squared minus 4, or 8 over x squared minus 4, same thing. So there's only one number you can never divide by in math, and that's 0. So if you take the denominator, set it equal to 0, well, what do we have? We have this. Now, to solve this, there's any number of ways you can do it. So one way to do it is, first, let's add 4 to both sides. That's going to give me x squared equals 4. Sorry, a little sloppy there. Take the square root of both sides. X equals plus or minus 2. So, or you can just say x equals -2, 2. Or 2, or you could say 2, -2. It doesn't matter. But you can check it, because if I plug in 2 here, 2 squared is 4, minus 4 is 0. 8 divided by 0 is undefined. If I plug -2 in, -2 squared is just 4, 4 minus 4 is 0, 8 divided by 0 is undefined. So now we're going to look at, okay, simplifying rational expressions. So suppose I have the expression x squared over x squared minus 4 times x plus 2 over x. So we're multiplying one rational expression here with another one here. So the thing is, when you're dealing with these kinds of problems, first off, you always want to see if you can factor anything. Well, here there's only one term, nothing to factor. What about here? Well, that's going to factor out to x minus 2x plus 2. Difference of squares. So it's going to become x squared over x minus 2 times x plus 2, or you could write it as x plus 2 times x minus 2 times x minus 2, excuse me, because it's multiplication. You can multiply and add any order, and you get the same result. So then I look at, well, x plus 2 here, can't factor anything out of there except for 1, but pulling out a 1 keeps it the same, because 1 times anything is itself. And here you just have an x. So there's nothing to pull out of there. So I have this. So now what happens? I'm going to pick a different color here. So what happens here? Oops. My bad. So x plus 2, those are gone. And then x squared divided by x, well, that's just going to be x. So let me undo that. Change it back. So I went having x here. So then it winds up equaling x over x minus 2. And that's it, because this is crossed out, and I have x here, so you wind up having an x over x minus 2. So now let me clear the whiteboard so I can fit in more problems on here. So now let's look at another type of expression where it's x plus y over 2y plus x minus y over 2y. Well, this goes back to the basic principle of adding and subtracting fractions. The only way you can add and subtract fractions, you have the same common denominator. Well, they do here because you have a 2y here and a 2y there. So we can just combine the terms. So x plus x is 2x. And y minus y is just 0, so that's gone. So we're left with 2x in the denominator. It's all over 2y. Well, then I can simplify this further because what happens here? Well, the 2's divide out. Let me redo that. So again, my bad, the 2's divide out. So the answer winds up becoming x over y. Now, this next problem is a little bit trickier because we want to having something a little more hectic. It's where we have complex fractions, where you have fractions within fractions, and it's one big fraction. I know I said fraction a lot, but let me just show you what I mean. So the example I have here is 2 over xy minus 1 over y, all divided by 2 over x plus y, or excuse me, 2 over xy plus 1 over y. So what you do here, this can be overwhelming. Looking at it, oh my God, what do I do? One thing I always say, don't let the math intimidate you. So you work with one part at a time. So let's look at the top part here. So we have 2 over xy minus 1 over y. Well, again, the only way we can add and subtract fractions, excuse me, the only way we can add and subtract fractions, so they have the same common denominator. Well, my denominator here is xy, here it's y. Well, I had to multiply this by an x so I can get xy. So x and x. So the 2 stays, and negative 1 times x is negative x. So it becomes 2 minus x all over xy. Now down here, now we work down here, and now I have 2 over xy plus 1 over y. Well, I have xy here and a y here. Well, I need to multiply this denominator by x so that now they both have xy in them. So what does that give me? 2, and then 1 times x is x, so 2, the plus sign there is 2 plus x. So 2 plus x all over xy. So now I have to divide these. So how do I divide fractions? Well, I take what I have in my numerator, right? Just like with dividing basic fractions, say like 1/2 divided by 3/4. And, I keep my numerator the same, 2 minus x over xy. And then I'm going to multiply by the reciprocal of my denominator, which is basically what that means is the numerator and denominator, they switch places. So now it's going to be times xy over 2 plus x. And now we want to see if anything cancels here. Well, we have xy here and xy here, so those disappear. So therefore, I am just left with 2 minus x over 2 plus x. Now, from here, you could take it a step further. Okay, yes, I could rewrite it in standard form. So in standard form, 2 minus x would be negative x plus 2. And in standard form, 2 plus x would be x plus 2. And then since I have a negative in front of here, I can pull out a negative 1, making it negative 1 times x minus 2 all over x plus 2. Now, as you can see, this problem does require work. It's a bit tedious, but it's one of the, if you can really do these kinds of problems, then the other problems aren't as difficult, because these are some of the hardest types you come across. And I'm going to clear my whiteboard. So the last problem we're going to talk about, or example of, is where we have an equation that involves rational expressions. So for example, I have 3 over z plus 1 equals 1 over 2z. So the best way to deal with a problem like this, I always, the best method to use is multiply both sides by the LCD, the least common denominator. So imagine you were adding these two or subtracting these two rational expressions. Well, what is our least common denominator? Well, you have 2z here and z plus 1 here. So therefore, the LCD is going to be 2z times the quantity z plus 1. And now this is important. You want to keep the in parentheses like that. Also, don't distribute it, because if you distribute this 2z, it's going to make it a lot more complicated. So I'm going to rewrite the equation like this. And I'm going to multiply both sides by my LCD, which again is 2z times z plus 1. So when I do that, the left-hand side I write it here, and of course on the right-hand side, 2z z plus 1, 1 over 2z. So what happens here? Well, does anything cancel out? Let's take a look. Well, on the left-hand side, z plus 1, that cancels. And on the right-hand side, 2z cancels. So now, what am I left with? I'm going to have 2z times 3 2z times 3 equals, well, z plus 1 times 1 is z plus 1. And 2z times 3 is 6z equals z plus 1. Subtract z from both sides. I get 5z equals 1. Divide by 5. Z equals 1/5. And then you can always plug it in to see if it works or not. So if I plug in 1/5 down here, 1/5 plus 1, that's 1 1/5, which is just 6/5. 3 divided by 6/5 is just going to be 3 times 5 over 6, which is just going to be 5 over 2. I plug in 1/5 here, I get 2/5. 1 divided by 2/5 is 5 over 2, so it works. Okay, so that's it for this video. I hope this helps, and everybody have a great and wonderful day. See you next time. Bye-bye.